Hello students, this video is about the scatter plots and correlation review from quantitative reasoning. What I want to do in this video is just walk through this problem about Amelia. It is a scatter plots problem, so you're going to be making a scatter plot, scale and labeling, that kind of happy stuff. And then once you have the dots on the graph, you're going to draw what's called a trend line. Let's start by reading the question. Amelia plays basketball for her high school. She wants to improve to play at the college level, and she notices that the number of points she scores in a game goes up in response to the number of hours she practices her jump shot each week. So practice makes perfect, right? She records the following data, so you can see that the first point here says she spent 5 hours practicing, and then she got 15 points in the subsequent game. In this one, she spent 10 hours practicing beforehand and she got 31 points. So it looks like as the number of hours goes up, the number of points scored per game is also going up. Looks like it's going to be a positive correlation. We're going to see that. We're going to check that once we make our scatter plot. All right, it tells us that step one is to scale and label the axes. So the x-axis is going to be hours practicing jump shot, and the y-axis is going to be points scored per game. It's always going to be in this class where the first set of data they give you is going to be x, and the second set of data they give you is going to be y. This is going to be the independent variable x, and the dependent variable is y. So for the x-axis, we're going to use this maximum value divided by number of lines formula and round up once we get a value. So the maximum value for the x's looks like it's 12, and I'm going to count the number of lines on the x-axis, and it looks like I have 6, 9, 10, 11. Looks like there are 12 lines. So couldn't have been easier. There's 12 lines. The maximum value is 12. So I'm looking at maximum value being 12, number of lines 12. I'm skipping by 1. And of course, this process is the scaling process. I also need to label, which means I'm going to put the name of the variable, which is hours practicing jump shot, as a label on this axis. And then for the y-axis, I'm looking at these values for y, and I see that there's never a number that's smaller than 15. So it wouldn't make sense for me to start at 0 and then go 1, 2, 3, 4, 5, etc. because I'm really missing, I'm really using none of those smaller numbers. So what I'd like to do is use what's called a break. A break allows you to skip a bunch of numbers at the beginning of an axis, so you're only graphing numbers that are relevant to you. So you can imagine that this part of the axis maybe used to be a straight line, but then somebody grabbed it up here and squashed it downwards, and it like folded in on itself. The break does that, right? It folds in the axis so that you're able to go from 0, which is down here, up to any number that you want, and then you can skip by smaller numbers as you scale up here. And then we have to figure out a value to skip by in order to reach 36. Well, I need to get from 15 to 36. That means I need to increase by 21. I don't think there's 21 lines here, right? If I counted out 2, 3, 4, 10, 12, there's 12 lines, right? So there's not 21 lines, so I can't skip by ones. But if I skip by twos, I should probably get there pretty easily. Let's see if I do. And yes, it does look like we're getting up to at least 36 here, right? The highest y value is 36. We got up to 37. Okie doke. And of course, you know the points per game is the variable represented by the y axis, so we are going to write that here. We, of course, need to scale and also label our axes. Perfect. Okay, so now step 2 is to graph the points. Graphing the points is very straightforward. This is the x and this is the y, 5, 15, right? So I'm looking here, I'm going 5 on the x-axis, and then 15 on the y-axis. This is the point that I'm looking at. All right, I'm going to throw up all these points here. If you'd like, pause the video and try to graph them yourself, and then see if your graph looks like mine. All right, looks like I have my points all graphed here. This scatter plot is a pretty straight scatter plot. It looks like my trend line is going to be almost a straight line exactly. So we graphed the points. That was step 2. Moving on to step 3. We're going to find the equation of the trend line. And remember, a trend line is a line that we're going to draw in a straight line that tries to go through the points where most of the points are very close to the line, and we have roughly the same amount of points above and below the line, right? So we're going to draw that trend line now. I'm going to use a straight line tool, but of course you're going to use your student ID or your Metro card. All right, looks like a nice trend line here. There's about 1, 2 points that are below, maybe 2 points that are above, and 2 points that are basically on the line. So I think I'm okay. It looks like a very trend line. Next, I'm going to pick 2 points that are on the trend line. So keep in mind, you don't have to select points that were in the data set. So I'm actually going to pick at least 1 point that was not in the data set. Right here, that trend line looks like it goes through that point exactly, and I know that that point is 6,19. It goes here, this is another point on it, but I don't really know what the x value is at that point. I know the y value is 17, but the x value is like 5.1, 5.2. I don't know, but this is pretty exact. So this point here is 6,19. That's going to be one of my points. And yeah, it turns out for the second point, I actually did select a point that was in the data set. 11,33 was one of the points that they gave to us. And remember, I only chose it because it was actually on this dotted line, this trend line. I didn't have to pick any of the points that were from the data set. All right, using the 2 points, we're going to find the slope using the formula y2 minus y1 over x2 minus x1. Let's label these points. Just writing down that this is my first x value, my first y value. This is my second x value, my second y value. All right, I'm going to find the slope using this formula, and that's going to be shown here. All right, you can see my slope formula here, y2 minus y1 over x2 minus x1. I substituted in 33 and 19 for my y2 and y1, 11 and 6 as my x2 and x1, and then I simplified 14 divided by 5. And if I turn it into a decimal, it becomes 2.8. I'm turning it into a decimal here because it's going to be easier to work with algebraically. We're going to be substituting it into y equals mx plus b in a moment here. Speaking of that, it says, as the next step, select the point on the line, then substitute the x and y values from the point, along with the slope, into the equation y equals mx plus b, then solve for b. I need to find the y-intercept. All right, so here's my m. So I'm going to write out y equals mx plus b. All right, so here's my equation, y equals mx plus b. I took the point 6,19, and I just picked it because the numbers were a little bit smaller, and substituted it into the x and y respectively. My m is 2.8, and then I simplified and solved, right? 2.8 times 6 is 16.8, and then subtracting 16.8 from both sides, I solve for b, which is 2.2. Now I have my equation, y equals 2.8, that's the slope, times x plus 2.2, that's the y-intercept. All right, so there's my slope and y-intercept. So now that I have this equation, remember this equation is something we call the equation of a trend line. And this equation is going to help us make a prediction for the future. It's going to help us extrapolate. So y equals 2.8x plus 2.2. Let's see if we can use this to extrapolate what's happening here. Amelia's coach suggests that she should aim for 45 points per game. How many hours should Amelia practice to achieve this goal? So it does say 45 points per game here. It seems to me that they're telling us that the value of y, which remember, if you look back at your graph as points per game is the y values, the value of y is going to be equal to 45. So what I'm going to do is I'm going to take this number, substitute it into my trend line, and then it says about how many hours should you practice. Well, hours practicing jump shot is x. So we're going to solve the equation here, once we substitute in for y, solve the equation here for x, get x by itself. Then we're going to have a prediction about how many hours Amelia should be practicing. All right, so you can see that I substituted in 45 for y, and then I subtracted 2.2 from both sides. Then I divided both sides by 2.8. I'm not going to teach algebra. You're in this class because it's after algebra. Okay, 15.2857 the number, the decimal keeps on going. But remember, this is a prediction about how many hours should Amelia practice to achieve this goal. So I'm probably looking for a whole number of hours. All the hours that were announced previously in the problem were whole numbers, right? 5 hours, 9 hours, etc. So I need to figure out what this means in the real world. Well, it's talking about real world hours. So I'm going to round it to the nearest whole number. Instead of 15.2857, I'm going to say 15 hours. Oh, well, actually, it says solve the equation so that x is isolated and round to the nearest tenth. Let's actually round it to 15.3 hours. Okay, perfect. Folks, that was the video on practicing scatter plots and correlation. We made a scatter plot, scaled and labeled axes. We picked 2 points on the trend line and found the equation of the trend line. And then we used the equation of the trend line to make a prediction about the future, to make an extrapolation on what the value of y should be if x is equal to a set value. All right, folks, good luck studying.